Hello students, my name is Santosh Kumar and I am the course instructor for Machining Sciences and Tool Design. We are in module number 1, that is metal cutting theory and dynamometry. So in this video we will discuss topic analytical modeling of machining operation. So that before 1940 there was no attempt made to do any modeling of machining operations. So they were only depending on the experimental results. So the performance of a metal cutting was purely judged by the experimental results. So this was a craft approach. Uh, so as you can see in this figure, there are many parameters which is influencing the cutting operation. So all these parameters affect or influence the cutting operation. So these effects were not studied earlier. So there was essentially no attempt to relate performance to the details of mechanics, such as stress, strain rate, localized microfracture, and temperature of the chip. So the details of mechanics were neglected in the experimental results. So that is what modeling does for you. It takes account of every details of the cutting and then do the modeling. So Pisman and Merchant were initially responsible for the major contribution to this aspect of machining, this aspect of modeling. So another important attempt to predict the metal cutting performance was whatever the laboratory test was done, like compression, torsion, and indentation. So these results were extrapolated using extrapolation techniques to the actual condition, that is actual metal cutting chip formation condition. So that is one more attempt which was made. What is this analytical modeling is basically you use a physics based analytical model is used to predict the temperature, that is performance, by induced by the cutting forces. So that is you use certain models like mechanistic model, slip line field analysis. Basically what you're doing in this is you develop a mathematical relation for the physical process which is happening, that is the cutting operation which is happening. You developed a mathematical equation. By this mathematical equation you are developing a coefficients. So these coefficients are used to develop the different other parameters that we will study in the next slide. Apart from this analytical model, there is also FEM based model, that is numerical modeling. So in case of FEM based models are able to simulate the cutting process for 1 or 2 revolutions and predicting any kind of physical phenomena describable by finite elements. So that is, if you can do the pre-processing in a FEM, so then you can simulate the cutting process for 1 or 2 revolutions. That is, you can give the boundary conditions or other things in a pre-processing, then you can simulate 1 or 2 cutting operations. That too much accurate. This is quite accurate method, but the computation cost is expensive compared to analytical modeling. So FEM based, both that is FEM based and also analytical modeling, that is mechanistic models, are used to applied to study the cutting forces as well as vibration, tool wear, residual stresses, and even metallurgical changes. So what you do in this analytical modeling is, as I earlier said, you develop a mathematical equation based on the physics of the problem, based on the physics of the cutting operation, and you obtain the coefficients. These are the foundation of mechanistic models. Even not so accurately, are able to calculate the cutting efforts for a complete tool path. So the most common models, that is, one is exponential one that is proposed by Victor, and then other one is a linear one for the plowing effect proposed by Amerigo. So in either case, the forces are proportional to chip instant area and the cutting coefficients which we have obtained empirically. So many that is both these models, that is mechanistic models and slip line field analysis, is discussed in detail in one more video. So we will end this video here. Thank